All right, good morning. So today we're going to go through the 811 task from the module. All right, so various notations are used to denote vectors. Right? Boldface type V is one way of naming a vector. Right? A variable written with a harpoon over it. Right? Again, we talked about that kind of half arrow over the V. All right, is one way to do it, and another way to denote a vector is by writing it with respect to its horizontal and vertical components. All right, so in this task, we will represent vectors by listing their horizontal and vertical components in a matrix, okay, with a single column. So, again, we are going to represent a vector using the horizontal and vertical components, but writing it in matrix form. Right? So right here is that little grouping symbol for matrices. So for example, here we see this vector, vector V. Right, so now again, in terms of horizontal and vertical components, right, we can write it, not like that, got an ordered pair, right, using the vector notation for horizontal and vertical components. So we have a horizontal component of 1, 2, 3, 4, 5, so a positive 5. And a vertical component of positive 2. Okay, so here's the vector V in terms of its horizontal and vertical components. So now we're going to rewrite this vector as a matrix. Okay. So vector V as a matrix, as again we're going to use the matrix grouping symbols, the brackets, squared off brackets. Alright, so again it's horizontal first and then vertical. So 5, 2. Okay. So here's the traditional horizontal vertical components of a vector, and here is it written as a matrix. Alright, so moving down here to the next example. So here we have vector W, which again represented as a matrix. Right, horizontal component of 2, vertical of 3. Right, from the starting point to the right 2, up 3. So again, written as a matrix, it's 2 over 3. This dotted line here is the reflection. So suppose we want to reflect vector W over the y-axis. So again, remember that's a flip over the y-axis. Alright, so the matrix that represents this vector is this one, negative 2, 3. Again, you can check that out from the diagram. From the starting point, we have to go to the left 2. So that means our horizontal component is negative. So we have the negative 2. And then we're going up 3. Our vertical component is 3. So negative 2, 3 represents the reflected vector W. Okay, so moving on to the next page, it says here, find the 2 by 2 matrix that we can multiply the matrix representing the original vector by in order to obtain the matrix that represents the reflected vector. Okay, so here we're trying to find these A, B, C, D values that when we multiply it by our original matrix W gives us, our original vector W that will get us this reflected vector W. Okay, so what I want you guys to do is I want you to pause the video here for a moment and see if you can figure out what the A, B, C, D values are. Alright, we're back. So, again, if you think about matrix multiplication, right, you need to do row times column. Right, so we do the top row times this column, that should give us our answer here. Alright, so if you're thinking about just the row times the column, then you should figure that the AB row should be negative 1, 0. Alright, because the negative 1 times the 2, which gets you negative 2, plus the 0 times the 3, which is 0. And when you add those two together, you get answer in the top here to be negative 2. Again, thinking row times column. Alright, you want the answer to be 3 here. So row times column, so the CD row has to be 0, 1. 0 times 2 is 2. I'm sorry, 0 times 2 is 0. And then 1 times 3 is 3. So add 0 plus 3 gives you 3. Alright, so now we want to be able to find the matrices that will do these different transformations of that vector W. Alright, so we want to do one where it reflects over the x-axis, rotates 90 degrees counterclockwise around the origin, 180 degrees counterclockwise around the origin, and then 270 degrees counterclockwise around the origin. Okay, so what I want you to do now is, right, then go back to the original diagram and draw those transformations. So again, we're doing rotations now. So 90, 180, and 270. Right, find the matrix that represents those different transformed vector W's and see if you can figure out the ABCD matrix that gets you those transformations. Okay, so we're going to do reflect over the x-axis, and you're going to do 3 rotations. Okay, so go ahead and pause the video here, and we'll see what you get here in a bit. Alright, so we want to at least be able to set it up. Alright, so we can figure out what these matrices that are going to do these different transformations. So again, for the number 3 here, we want to reflect W over the x-axis. Alright, so here again, I drew the various transformations. So this one right here, this vector right here is the reflection of vector W over the x-axis. So it's flipping it over the x-axis. So this vector, which represents the reflection, right, has horizontal and vertical components of positive 2 and negative 3. So then I'm going to write them as a matrix. Right, so for this vector right here, got to go 2 to the right and then down 3, so 2, negative 3. Right, so I need to figure out what matrix, when I multiply by the original W matrix, is going to get me this. So again, if we think about row times column, right, so I want to do the first row times this column, I need it to be a positive 2. So I'm going to have that first row be 1 and 0 for my AB, right? Because 1 times 2 is 2, 0 times 3 is 0, 2 plus 0 is 2. Row times column, I need it to be a negative 3. So I'm going to have my C value be 0. 0 times 2 is 0. But I need my D value to be negative 1. So again, when I do row times column, 0 times 2 is 0. Negative 1 times 3 gives me negative 3. Alright, so for the next one, we got the 90 degrees counterclockwise rotation. So again, back to my diagram here. Alright, so this vector right here is my 90 degrees counterclockwise. So remember we talked about it in the transformation module. Alright, it's about slopes that are opposite reciprocal for 90 degrees. So, alright, so I did that application to get my 90 degrees counterclockwise version of vector W. Alright, so the horizontal component for this vector is negative 3, vertical positive 2. Okay. So for this one, right, again, horizontal negative 3, vertical positive 2. 90 degrees counterclockwise. Alright, so I want to figure out what matrix do I need to multiply my W matrix to get this. Alright, so again, for this one, we're thinking row times column. So I want this 2 to go away. So I need that A value to be 0. Alright, but I need this B value, this 3 to be negative. So I'm going to change that B to a negative 1. Alright, so I'm going to go row times column. 0 times 2 is 0. Negative 1 times 3 is negative 3. 0 plus negative 3 is negative 3. Okay. Second row, by column, I need n to be a positive 2. So my C value, I'm going to make 1. And my D value, I'm going to make 0. So when I do row times column, 1 times 2 is 2. 0 times 3 is 3. 0 times 3 is 0. 2 plus 0 is 2. Alright, so here's the matrix that's going to get me my 90 degrees counterclockwise. Alright, again, this was the matrix up here. They helped me did a reflection over the x-axis. Right. So now moving on to number 5, where we're doing a 180 degree counterclockwise rotation. So again, seeing what that looks like. Here's my vector W. Here's the vector that represents 180 degrees around the origin. All right, so again, reminder that 180 degrees is we keep the same slope. Right. So, but for this vector, we have to go horizontal -2, vertical -3. So here my resulting vector, I want -2 over -3. Alright, so again, trying to figure out what matrix I'm going to multiply by W to get this 180 degree counterclockwise rotation. Right, so I want my A value to be -1 and my B value to be 0. Row times column gets me -2. Second row, this row times this column is going to get me -3. So here's a matrix that's going to help you do a 180 degree rotation around the origin. Okay. Alright, and this next one, 270 degrees counterclockwise. So what that looks like, it's this vector right here. That's my 270 degrees counterclockwise. The horizontal component of that is 3, vertical -2. Alright, so here's that result, 3, -2. So now again, I need to figure out what matrix that I'm going to multiply my W matrix by to get this rotation. So again, we think row times column, so I need this to be a +3. So my top row is going to be 0, 1. 0 times 2 is 0, 1 times 3 is 3, 0 plus 3, 3. Row times column, I need that to be a -2, so -1, 0 is going to get it done. -1 times 2 is -2, 0 times 3 is 0. Add those together, you get -2. So here's the matrix that's going to do a 270 degree counterclockwise rotation. Okay, so I'm going to stop this video here right now and continue on to the next video. So I want to go ahead and head over to video number 2 for today's lesson.